So in this topic, we are learning how to connect a game to the internet so that it can send and receive data. This means our game can access information from online sources, making it more interactive, dynamic, and connected to the real world. So let's break down what we are covering and why each part is useful. So first topic would be dynamic sky visuals. We'll start by discussing about creating a sky that changes based on real world weather data. For example, if the actual weather is rainy, the game's sky can reflect that. So this feature adds realism to the game by uh, connecting it to live weather conditions, making players feel more immersed. And next topic is understanding HTTP request. So HTTP, hypertext transfer protocol, is a standard way devices communicate over internet. So HTTP get request asks for data from the server. For example, you might use it to get weather data. And we have a HTTP post request which sends data to the server, like recording a player's score. HTTP requests are the backbone for online communication in games, allowing them to get information from or send updates to online services. And the other topic is coroutines for network requests. So coroutines in Unity lets us pause a task until a response is received from the server without freezing the game. So this is crucial in games because if the game paused every time it waited for data, it would feel slow and unresponsive. So with coroutines, players can keep play players can keep playing while the game waits for an internet response. And we'll also discuss about data formats, XML and JSON. So when we receive data from the internet, it's usually it usually comes in a standard formats like XML or JSON. XML is extensible markup language. JSON is JavaScript object notation, which are standard way to organize data for easy reading and retrieval. We also have parsing. So parsing data means breaking it down into parts that Unity can understand and use in the game. For example, we might parse JSON weather data to see if it's sunny or rainy and adjust the sky visuals accordingly. And the other topic is downloading and displaying images. So we'll also download images from the internet and display them in the game. So this is useful for showing things like weather icons, profile pictures, or even game maps. And we'll also discuss about setting up a simple server. Sometimes games send data to a custom server, like saving player stats or recording high scores or tracking player activity. So in this topic, we'll see how to set up a basic server which we can use to send data like game logs or save player progress. So having a server lets us save data across sessions, keeping track of things like inventory levels or high scores even after the player closes the game. So why this matters for games? Because many games today are online, meaning they require internet connectivity for things like multiplayer modes, live events, or leaderboards. So even games that aren't fully online benefit from connecting to internet to show live scores, track player behavior, or add a special online only features. So learning to work with HTTP request and parse data helps you add these kind of features to your games, making them more interactive. personalized and engaging for players. So by understanding these topics, you'll add a you'll you'll be able to add online features to your Unity games, opening up a whole new range of possibilities like real-time updates, data tracking, live game adjustments. This knowledge would be a foundation for creating more connected and responsive gaming experience. So first is creating a dynamic outdoor scene. So in to create a realistic outdoor uh, to create a realistic outdoor environment in Unity, you need to set up materials, a skybox, and create a way for the skies to respond to changing weather. So let's discuss each step. First step is applying outdoor textures. Choose and download textures. Get realistic images from the ground for the ground and walls from sites like textures.com. Make sure to resize them uh, to power to two dimensions, 256 by 256, which is important for Unity's optimization. And import and create materials. Import Basically, you'll import these textures into Unity and then create materials and add these textures to them by just dragging these images into the materials texture slot. And last step would be assigning these materials to the walls, floor in the scene by dragging them onto each object, increasing the tiling uh, to avoid any stretched or a blurry look on the surfaces. And next step, second step would be setting up the skybox. So the skybox gives the illusion of an open sky surrounding your scene. So choose skybox images for dynamic sky. Use two sets of images, one for clear sunny day, one for overcast or stormy sky, and import and adjust the settings. So import these sky images into Unity, change their wrap mode to clamp in the inspector to avoid visible seams in the skybox. And then you can create a skybox material. So in Unity, create a new material, set its shader to skybox six sided, which allows for 6 different texture slots, one for each side of the skybox, and assign images to the skybox materials. So drag image each skybox image, which is the front, top, left, right, back, and bottom, to its respective slot in the material. Unity will use these to surround the scene in a 3D sky, and apply the skybox to the scene. Excuse me. So when you open up the lighting window and go to the environment tab, set its material as a skybox material in for the scene, and you'll see the sky will surround the player's view. And the last step would be creating a dynamic sky for with a custom shader. So Unity's default skybox shader is static, meaning it won't change based on the weather or time. To make the sky adjustable to the for things like weather changes, you need to download a blended skybox shader. You can find a custom shader which is called skybox blended.shader on GitHub. This shader allows for smooth blending between two sets of sky images. And next step would be adding the shader to your project. So create a new shader and name it skybox blended with a standard surface shader. And then we'll write the code for the shader code. You can use the GitHub code. So the shader code enables blending between two sky images allowing you to transition smoothly between sunny and cloudy skies. So with that, you will have a outdoor scene ready to respond to changing weather conditions. So the textures create a realistic ground and walls, while the custom skybox shader will let you adjust the sky between clear and stormy based on real-time data. So this setup is ideal for games or scenes where dynamic environmental changes enhance the atmosphere, making the experience feel more immersive. So, so to create a atmosphere that changes from sunny to overcast in Unity, we can blend between two sky images, one for sunny weather, one for cloudy, and adjust the scene lighting to match. So, so first step is setting up the skybox with custom shader. So a shader is a small program that tells Unity how to render materials. We'll use a shader that can blend two skybox images smoothly, allowing the sky to change based on weather. So first, you need to download the Skybox blended.shader code from GitHub, which has a built-in functionality to blend two different sky images. And then you'll in Unity you go to create shader and you'll find the standard surface shader and name it to Skybox blended and paste the you can paste the shader code. And next step would be creating the skybox material. So create a new material in Unity, set its shader to skybox blended, the shader we discussed about. So in this material settings, you'll see 12 texture slots. First six are for sunny images, and the last six are for cloudy images. So assign each of the skybox images to the correct slot based on the sky state. Uh, so after setting up both set of images, try adjusting the blend slider in the materials inspector. This will smoothly transition the skybox between sunny and cloudy skies. And the next step would be automating the transition with code. So now that we have skybox material we that can blend between sunny and cloudy skies, we need to write a script that changes this blend automatically over time. So for that we create a controller object and a script. So in Unity create a empty game object in the scene and name it something like controller, and also you'll create a new script called a weather controller and attach it to the controller object. And let's open the weather controller script. So in this weather controller script, variables we have sky, sun, which is a reference to uh, which is uh, a reference to skybox material, which we will adjust. And sun is basically a reference to the main light, usually a directional light representing the sun. And we have full intensity. So intensity stores the original brightness of the sun, so we can scale it down smoothly. And what else we have? So in the start method we save the initial intensity of the sun. This value will be used to dim the sun when it becomes cloudy. And in the update method, so which runs every frame, we call the set overcast cloud value, which is a here it's mentioned as value, but yeah, so it's cloud value to update the sky's appearance and then increase the cloud value slightly. So this makes the sky slowly transition from sunny to overcast over time. And here the set overcast method does two things. It calls sky dot set float blend value, which is the blend parameter in the shader, controls how much for each sky image set is shown. At 0 it's fully sunny, at 1 it's fully cloudy, and it also adjusts sun dot intensity based on the cloudiness. As cloud value goes from 0 to 1, the sun's intensity decreases, making the scene dimmer. So when you press play, you'll see the sky gradually change from sunny to cloudy, and the lighting dims to match the overcast atmosphere. This effect can make your scene feel more dynamic and immersive. So one important note here is Unity's editor keeps the change in cloud value permanently for the material. So if you restart play mode, the sky might start where you left off instead of setting to sunny. So to avoid this, reset the cloud value in the script, or manually reset the sky's materials blend slider after stopping the play mode. So this code driven sky blending provides a basic customizable system for changing weather in Unity. So next we'll use this setup to sync the in-game weather with real world weather data. So next in this part, we'll discuss about setting up a way for our game to access weather data over the internet. So we do this by structuring our code so that each part has a specific role. We have a weather manager. So weather manager handles weather related risks, tasks like retrieving and storing weather data. And we have network service which is responsible for making HTTP requests to fetch this data from the web. So this setup will let us pull real world weather data into the game. So which will use to dynamically change the game's environment, like the skybox, to match actual weather conditions. So let's break down each part. So first, web requests allow programs to communicate over the internet. For this project, we are using the Open Weather API to get weather data like sunny, cloudy, rainy. API stands for Application Programming Interface, which is a way for programs to talk to each other. So we'll be using HTTP request, which is a common method for making web requests. Get requests retrieve data from the web server like the weather information. Post requests sends data to the web server if you want to log in or save data. So the weather data we get from Open Weather will be in a format called JSON, which is a JavaScript object notation, which is easy to read and use in Unity. So next is structuring the code. So to organize everything, we are using a pattern from previous topic called manager's architecture. So in this setup, each manager, like the weather manager, handles a specific part of the game. So we have a script called managers, which we discussed, that controls and initializes all managers. So we'll also create a network service to handle HTTP request for us. So this service will allow other managers to connect to the internet and request data. So next is the code. So first we need a interface called iGame Manager. So to define a basic structure for all managers in the game, so interfaces make sure that every manager has the required properties and methods, creating a consistency across managers. So in this case, we'll require a status property uh, to indicate the manager's current state, and a startup, which startup method to initialize the manager. So here the manager status is enum, which is a type that defines a fixed set of values. So in this case, shutdown means in this code it's not mentioned, but usually you'll have a shutdown means the manager is not running. Initializing means it's starting up, and started means the manager is fully up and running. Next, we create a weather manager. So weather manager to handle the weather data. So this manager will implement iGame manager, meaning it must include the status and startup methods. So here the status properties getter uh, is public, so it can be accessed outside of this script, but its setter is private, meaning meaning only weather manager can set its own status. And the startup method is where we initialize weather manager and set its status to started. And the network service is saved to a variable called network. So here later we'll use this variable to make the HTTP requests for weather data. And next we need to update the manager script. So we need to update the manager script to include the weather manager. So managers will be in charge of creating and starting up the weather manager, and will also provide access to it. So in the managers, we use static property to make the weather manager accessible throughout the uh, throughout the game. Whether it's static, meaning it's shared across all script without needing to an instance of manager. And in the awake method, managers references weather manager with get component, and also we have adds weather manager to start sequence list, and calls the startup manager to start each manager. So the startup managers is a coroutine uh, which runs asynchronously, which initializes each manager by calling the startup on it. So once the code is written and attach the managers and weather managers to an empty game object in your Unity scene, and when you run the game in Unity, if everything is working, you should see a startup messages in the console indicating the weather manager has started. So we discussed about setting up a basic structure for downloading weather data, where weather manager handles weather specific tasks, and network service, which will discuss later, will manage the actual network request. Managers initializes everything, making sure weather managers and network service are ready to use. So this foundation will let us add code to the weather manager for making HTTP requests using network service to download real-time weather data. So next is so let's go deeper into each part of this process to make sure it's easy to understand. So this part of the topic is all about downloading the data from the internet in Unity and using HTTP request. Unity provides a tool called Unity Web Request that we will use to communicate with the internet and retrieve information like weather data. So what is a HTTP request? An HTTP request is a way to send and receive information over the internet. For example, when you visit a website, your browser sends a request and the website sends back data. Uh, in Unity, we can send HTTP request to services online like weather service to get data that updates in real time, which we can then use to adjust things in our game. So Unity has special, as I mentioned, Unity has special class called Unity Web Request that lets us request data from the URLs on the internet. So this class can retrieve information like weather, news, scores. In our case, we are getting weather information. So coroutines are another important concept here. Coroutines lets us run certain code in the background without freezing the game. So this is helpful, useful for things like waiting for a web request to complete. So with coroutines, we can pause until the data comes in without stopping the whole game. So in Unity, we use yield return inside coroutines to pause a function and wait for certain conditions before resuming. So let's go back to the network service code. So here uh, we are setting up the URL. So the line private const string. So this line sets up the URL for weather service. Will replace uh, API API key with our with your own API key to get access to the data. And next step would be creating the call API coroutine. So the call API call API method is the main method of requesting data from a URL. So IEnumerator is used here to because we need to pause this function while we wait for the data to download. And next would be setting up the request. So Unity web request request is equal to, so this line creates the request to get data uh, from the from the given URL. And this the using statement is used uh, this using statement is used to make sure the memory is released once we are done with the request. And next step would be waiting for the request to complete. So yield return so yield return request dot send web request sends the request and pauses until the request completes. So this line stops the code and waits for the web data to come back. While waiting, the rest of the game keeps running normally, uh, thanks to the coroutines. So next, after the request finishes, it checks for errors. The connection error happens if there's a network issue, if you're offline. And protocol error happens if there's an issue with the data sent back, like if the URL was wrong. And if everything goes well, it goes to callback callback function, uh, callback request dot download handler dot text, which sends the data back to another function using a callback. So a callback function is a function passed as a parameter, so we can use it later in another function. So here action string callback uh, means callback function expects a string, which is our data, as input, and this get weather XML. This function is simpler and acts as a way to call the call API. So it's called by other classes like weather manager to start the request and pass a callback function to receive the data once it's ready. Uh, so now let's go back to so let's see how to connect network service to our weather manager, which controls what happens with the weather data. So weather manager, so in the weather manager we initialize the network service. So startup takes in network service so that it can access the web functions, and is equal to service stores the service so that other methods in weather manager can use it. And the start coroutine uh, starts the coroutine get weather XML, which requests the weather data, and then we pass on the XML data loaded as the callback function, meaning that once the data is downloaded, on XML data loaded will receive it. And so the on XML data loaded, which is a callback, uh, this method is called when the weather data is ready, and the data, which is a string, is passed into this method. The debug.log, which is not debug.log, uh, yeah, I'm not mentioned the debug.log data, which basically it prints the data in Unity's console, allowing you to confirm the downloaded uh, to confirm it downloaded correctly. So it's not in here, but you can use it. So status manager status dot started updates the manager status to started once the data has been received. So here what's happening is network service sends an HTTP request to get weather data, and the call API coroutine handles the request, waits for a response and checks for errors, and the callback function allows us to pass the response back to the weather manager, and the weather manager receives the data, displays it in the console and updates its status to start it. So with these steps your game can now make HTTP requests, retrieve data from the internet and use it however you want it. So next topic is parsing XML data for weather updates. So let's walk through this process by focusing on understanding each piece and how it works together. So the goal here is to pull weather data from an online service and use it to change our game's environment. Specifically, we'll look for cloudiness data and then make adjustments in the game scene based on that information. So to make this happen, we need to retrieve, parse, and broadcast this data so it can be used in different parts of our code. So XML, XML, as you know, extensible markup language, is a format for structuring data. You'll see tags and attributes used to represent information, similar to how HTML works. So our goal is to retrieve the value attribute, which tells us the percentage of the cloudiness, And parsing means breaking down the XML string into usable parts. Unity using C Sharp's XML tools lets us load XML data into a structure where we can navigate and pull out specific information. Broadcasting basically sends messages across the program, where when our cloudiness data is ready, we use broadcast to inform other scripts. So this is useful because it allows different parts of our program to uh, listen for updates without directly depending on each other. So to allow for message broadcasting, we'll add a messenger system in our project. So this makes it easy to send updates across scripts without making them directly dependent on each other. Uh, so add a new script called messenger from the uh, and also you'll create a second script called game event. So this script simply lists events that can be broadcasted. So here we'll add an event called weather updated. So let's go back to the code. So messenger so game. So in the game event we have so these lines we have weather updated. So we should be ready to broadcast weather updates across our game. As for that, we need to modify the weather manager for XML parsing. So next we need to adjust the weather manager script to parse XML data and broadcast updates when new data is available. So yeah. So first, creating and loading an XML document. So XML so this line creates a empty XML document, and load XML data, which loads XML data string into the document. This process structures the data, letting us find and extract specific elements. And the XML node root is equal to document element, which defines the root of the XML tree. From here we can search for elements and attributes within XML. So in the XML node so this line finds the clouds uh, element in the document. This element contains the cloudiness value we need, and next is extracting the cloudiness value. So for that, this line, string value line, retrieves the value attribute from the clouds, which might contain a value like 40, which is meaning 40% cloudy. Uh, and next line, cloud value, uh, which converts this 0 to 100 percentage to 0 to 1 float. This format 0 to 1 is better suited for Unity, especially for things like material or lighting adjustments. And next step would be broadcasting. So messenger dot broadcast sends out some message that the weather data is ready. So this message can uh, can now be picked up by any part of our game that is set to listen for a weather updated event, allowing us to make visual updates without direct dependencies between scripts. And the last line, status line, status equal to manager status dot started, which updates the manager status to show that we have finished initializing and processing the weather data. So here we discussed about pulling raw XML weather data, parsed the XML to extract the cloudiness value, converted this value to into a reusable format, which is the 0 to 1 float, and broadcasted weather updated events so that other parts of the game can respond to the new data. So with this setup, we should be prepared to use the parsed cloudiness value to change the game's atmosphere. For example, you can adjust lighting, skybox visuals, or other scene elements to reflect the current weather conditions in real time. So this approach gives a flexible, decoupled way to manage game updates based on external data sources. Uh, let's go back. So next step would be, so to work with JSON data in Unity, we'll explore how to download, parse, and use JSON to dynamically manage data from a weather API. So this is helpful for creating responsive game scenes that reflect real-time conditions, such as changing the sky-based weather data. So first step would be understanding JSON format. So JSON, which is a JavaScript object notation, is a lightweight format commonly used for data transfer over the internet. So it's structured with key value pairs that make it easy to access specific pieces of the information. So JSON is simpler and more lightweight than XML, which is why many web APIs use it for data exchange. So next step would be installing JSON parser in Unity. So unlike XML, Unity doesn't have built-in JSON parsing capabilities. We can, however, use JSON.NET, which is also known as Newtonsoft JSON, which is a popular library for handling JSON in .NET, which is compatible in Unity. So first we need to install JSON.NET. Go to the packages folder in your Unity project and open the manifest.json file and add the JSON.NET as a dependency. You can follow in the instructions from the JSON.NET package. So Unity will automatically download and install JSON.NET for you. And next step would be setting up a new weather API request for JSON. So to request JSON instead of XML data from the Open Weather API, you need to modify the network service script slightly to use a different URL. So in the network service script, so we need to replace the API key with your actual Open Weather API key. So we'll set up a method to call this JSON URL. We can use a coroutine to handle the request, allowing it to pause until the game is data is received. You need to change this. So yeah, JSON was not added in this code, but yeah. So basically the JSON method is similar to the one we used for XML data, except it calls JSON URL. It uses a callback, which is a reference to another function to pass back the JSON data once it's received. And you'll also modify the weather manager to handle the JSON data. So in weather manager, we'll update the startup and on JSON data loaded methods to handle the JSON response. So for that, we'll update the startup method to call the JSON weather. So we'll update the startup method to call the JSON weather request coroutine, and in the on JSON game loaded method, we use JSON.NET, which is a J object, and a J token classes to parse the JSON response. So some in JSON parsing, we have a deserialize versus parse. So parsing breaks down the JSON data to make it reusable, while deserializing converts the JSON into a defined C# script. So JSON.NET supports uh, both methods, but in this example we use JObject.parse because it's fast and efficient for single value. So here we discussed about how to use the API endpoint with JSON output. and how to use Unity's web request with the coroutine to make the JSON to make the HTTP request. And we discussed about extracting the relevant data using JSON.NET's Net's JObject and JToken classes. And we also discussed about sending a message to with updated data so that other parts of the program can respond accordingly. So with this setup, we can now dynamically adjust games visual based on real-time weather data, creating a more immersive experience. So this example explains how to retrieve JSON data from a web API, parse it and integrate it into Unity. So the last topic for today is uh, we'll go through the we'll go through how weather controller script updates the game's sky and lighting based on live weather data, especially how it uses cloudiness value to adjust the scene. So the goal is to make the sky transition smoothly from sunny to cloudy, depending on the cloudiness percentage from the real world weather data. So in the game, this happens by adjusting two key elements. The first one is skybox, which is the background visuals of the sky, and the other one is sunlight intensity to make the scene appear darker when it's overcast. So let's go to the weather controller data, weather controller script. So here variables. So as I mentioned, we have sky, sun, which sky refers to skybox material. We use this to change the sky visuals between sunny, cloudy. Sun refers to the main light in the scene, which is typically a directional light, simulating sunlight. Full intensity stores the original intensity of the sunlight. We use this as a reference to reduce the light's brightness as it becomes more cloudy. And yeah, void on enable and on enable, this function is called automatically when the script is activated, like when the game starts. So here we set up a light listener using the messenger system. The listener waits for a message labeled weather updated, and on disable, this function is called when the script is deactivated. It removes the listener so it doesn't keep checking for the weather updated message when the script isn't active. So why we use listeners? Because this setup allows to receive updates from the weather manager whenever new weather data is available. So the weather manager sends out weather updated message, which triggers the on weather updated function. So next step would be setting up the initial light intensity. So the start function saves the starting intensity of the sunlight in the full intensity variable. So this way we know that full brightness is when it's sunny, and we can reduce it when the sky becomes overcast. And responding to the weather data. So here when the weather updated message is received, on weather updated is called. So this function retrieves the cloud value uh, from the weather messenger and pass it to the set overcast. So here this line, the blend property on the sky material determines the skybox look ranging from sunny to cloud. The value, which is of 0, shows the sunny sky fully, while a value of 1, uh, which is 100%, shows the cloudy sky completely. Any number between the two creates a gradual transition. And the light intensity, this line dims the sunlight based on the cloudiness level. When the value is 0, which is sunny, and the intensity is at full intensity, as the value increases towards 1, which is full cloudiness, the sunlight intensity decreases, making the scene darker. So basically, weather manager receives updated weather data, including the cloudiness value, and the messenger sends out the weather updated message, and the weather controller script detects this message using on weather updated and runs the set overcast, and the set overcast updates the skybox visuals and sunlight intensity according to the cloudiness value. So with this setup, the skybox smoothly transitions between sunny and cloudy. The sunlight dims as the sky becomes more overcast. So this setup creates a dynamic real-time sky effect based on the live weather data. So the code is efficient and straightforward, making it easy to adjust and expand. So in the next session, we'll discuss the rest of the topics.